What we're going to do today is we're going to look at how we test a claim about a standard deviation or a variance. So remember in Chapter 8 we're doing one sample. In Chapter 9.4 we'll look at how we test two samples with how they compare to each other. So that's what our plan is for this section. So let's look at how to test a claim about a standard deviation or a variance. So we're going to look at a claim, and remember standard deviation is not squared, but variance is. And we're going to use the chi-squared distribution again. And here's the notation. It should be pretty familiar to you now. N is our sample size. S is the sample standard deviation. That's our statistic. Sigma is our population standard deviation. That's our parameter. And then both of those squared would be our statistics, our statistic variance, and our parameter variance. So things that are important, again, as with all the tests we've studied so far, a simple random sample is important. But with our test of standard deviations, the population normal distribution is more strict than it has been for our other tests. Now we are going to look at the critical value method, okay? But we're going to focus on doing the p-value method, and we'll use StatCrunch to do that. All of them will always lead to the same conclusion. So as we looked at back in Chapter 7, I believe, is when we have the chi-squared statistic, it's not symmetric, and all the values are positive. And as our degrees of freedom go up, the shape of the distribution gets more and more normal or bell-shaped. Now what we're going to do is we're going to use our degrees of freedom, and that's the number in our sample minus 1. We're going to use table A4 to find the critical values, and again what we do when we do that is we're setting up our region of rejection. So here is some data, and this is the example. If you have the 13th edition, this is the example that's on page 401 in your text. And so we're going to take this sample and we're going to do the descriptive statistics on it. So first of all, they tell us it's a simple random sample, and they're going to use a normal quintile plot to check the normality. I'm going to tell you we're not going to do that. If they tell us the population's normal, we're going to believe them. And then we go to StatCrunch and we look at the data. Now, as you can see, it calculates our chi-squared statistic for us right there. 16 in our sample, so our degrees of freedom is 15. Our sample variance was 3.4. And then we want to check to see if our hypotheses are that our variance is equal to that of the population, or is it less than that of the population. So that's where the number 56.25 comes in. And you'll see that the p-value is very small. So again, we're going to write our hypotheses. Now, what they did here is the original statement wanted us to look at a standard deviation of 7.5 centimeters. I'm going to go back here and notice that in StatCrunch they deal with the variance. So we took 7.52 squared. That's where the 56.25 comes in. We're going to choose our level of significance. That's alpha equals 0.01. And again, we're going to use the chi-squared distribution. And we've got that all taken care of right here. And you can see what our results are. Now, because our p-value is less than alpha, we reject our null hypothesis. So, in stat talk, there's sufficient evidence to support the claim that female supermodels have heights with a standard deviation of less than 7.5 centimeters for the whole population. So, and then this part would be our more regular language. I would write it, these data suggest that heights of supermodels do vary less than the heights of women in the general population. That's our everyday language summary statement. I'm going to do the critical value method. If you don't want to, skip up to slide 26. And you can fast forward the video so that you can see that. But we're going to look at the critical value method because I think that gives us an understanding of what's happening in StatCrunch. So what we're going to do is we're going to calculate our chi-squared statistic. So notice what we have is we have our degrees of freedom. We're going to take that difference times our sample variance, and we are going to divide by the population variance, and we get our chi-squared statistic. What we're going to do is we're going to find that critical value. Okay, I just pulled in table A for chi-squared distribution, and remember for that it's the area to the right of the critical value. So you need to be careful and you need to remember that. So, and I don't want to write a note. So the area to the right and our significance level of 0.01, we're going to concentrate here on our 0.99 column. And remember, we had 16 individuals in our data set, so our degrees of freedom is 15, and that's how we get. But anyway, as you can see right here, this is where I'm going to get that 5.812, which is my critical value. So that's how that comes about. So now you can see where we get our critical value, and so our critical value sets up right here. Now our test statistic is to the right of the critical value, meaning that it is in the rejection region. So that area that's to the right of our critical value, that's the rejection region. And I'm just going to do RR for rejection region because I'm writing with a mouse, so it's kind of a little bit difficult. So again, we can reject whole because of where our test statistic falls in the distribution. And so again, when we look at this using the critical value, we have sufficient evidence to support the claim that supermodels have a standard deviation with less than the 7.5 centimeters that it is for the whole population of women. So again, we can also do this with a confidence level, but I'm going to tell you I don't recommend this. And so if you want to look at how to do that, then you go ahead and you look at page 402 and read through how to do that. But again, I don't recommend that. Okay, let's go ahead and let's do a couple examples. I'm going to do this example with the summary statistics, and then we'll do another example that we have to analyze the data. So that's what my plan is. And if you have the 13th edition of the book, this is on page 406, number 11. So as you can see, we've got coffee machines, and we've taken a random sample of 27 cups. They have the mean of 7.14 ounces and a standard deviation of 0.170 ounces. We're going to use a 5% significance level to test the claim that the machine dispenses amounts with a standard deviation greater than the standard deviation of 0.15 ounces specified in the machine design. So remember, step one is always to do our hypotheses. And our null hypothesis is always a statement of equality. So we're going to say that the standard deviation equals 0.15 ounces. Or we could say the variance equals, and we have to square 0.15, 0.225. Then our alternative hypothesis, they tell us right here, is the standard deviation greater than what we assume, greater than the design specified standard deviation. So it's greater than 0.15 ounces. Or alternatively, we could say that the variance is greater than 0.225. And those would also have units of ounces. Then 2, we're going to set our alpha. Alpha equals 0.05 because that's what they told us right there. Then 3, we're going to summarize the data. So n is 27. The sample mean is 7.14 ounces. The sample standard deviation is 0.17 ounces. Okay, and then step 4, we're going to do our test. So we're going to do chi-squared test of standard deviations or of variance. Okay, and our formula is, and I would recommend you write it down even though you're not going to do the calculations by hand, n minus 1 times s squared over sigma squared. And then we're going to go to StatCrunch. So let's do that. So when we're in StatCrunch, we're going to go to Stat, Variance Statistics, one sample with summary, and the sample variance. Okay, our sample variance was, what is it, 0.0225? I think so, because we're thinking it's equal to 0.17. Nope, it's going to be 0.17 squared. And that's going to be 0.0289. And our sample size was 27. Now, notice what we have next is we've got our hypothesis test. That's what we want, but we need to change that number there. So again, we want to put in our 0.15 squared, which is going to be 0.0225. And notice how that filled in for us in our alternative hypothesis. And then we wanted it to be greater than, so we're going to do that. And then we're simply going to do compute. Okay, so now we have our results. I'm going to snip my results using my snipping tool, and then I'm just going to snip that options box. I'm going to copy it, and then I'm going to go back to my whiteboard and I'm going to paste it in there. Now when you're doing this, I would assume you're going to do it on paper or in a Word document. If you're working in a Word document and you want to do the equation, use the equation editor. It's not that difficult, but you might want to practice. I'm going to go ahead and now let's go back to the whiteboard. Get rid of that again. Let me paste in a picture. I was in my pictures, and there's my chi-squared. So now I have my results there, and I'm going to just make that a little bit bigger so that I can actually see it. Okay, so now let's look at what's happening. I have an extremely small p-value. So let me go back that I know my p-value is less than alpha. So that means, and 3 dots in math means therefore this is statistically significant. So when something's statistically significant, I have evidence against my null hypothesis. So I can reject my null hypothesis. And that's all that ever goes in step 5. Step 6 is going to be my summary. These data strongly suggest, because my p-value is very small, that the machine standard deviation is greater than 0.15 ounces specified in the machine design. Okay, and now I got an awful lot of that. Let me do a highlighter here. I got an awful lot of that phrasing right out of the problem. So there's my 6-step test. Okay, so what we're going to do now is we're going to look at number 15, which again, if you have the 13th edition, is on page 406. And we're going to look at drive-through service time in seconds at McDonald's during dinner times, and then also at Wendy's. We're going to assume that dinner service times at Wendy's have a standard deviation of 55.93 seconds. We're going to use a 0.01 significance level to claim that the service times at McDonald's have the same variation as at Wendy's, and we're going to talk about should we take any action. So let's look at that. I'm going to pull up the data set. We're going to do it with the entire data set. So let's look at that. And so I'm going to go to StatCrunch. And when we use a data set from our textbook, we use this link right here. And I want to do data set fast food. And you can see I have all kinds of stuff here. So let's read what this says. Oh man. I want to see what these things are. McDonald's lunch, and I bet that's McDonald's dinner. Let's just make it bigger so we can see. Yep. So we want to deal with this second column. I want to go stat Again, I'm going to do variance statistics, one sample, but this time it's with data. And I want to do McDonald's dinner. And again, I want to look to see what this should be. So I have my columns that I want to do. I need to do my hypothesis test. What we're looking at to see if it's the same thing as Wendy's, and Wendy's is 55.93, but we have to square that because that's a standard deviation. So we want to put in 3,128.1649. Okay, and it says test the claim that they have the same variation. Okay, so that just means it's either equal or not equal to, so we're good on our alternative hypothesis. So let's go ahead and let's compute and let's see what we get. So here we get our sample variance, our degrees of freedom, because we had 50 individuals in our data set. You get their chi-square statistic, and there's our p-value. So let's go ahead and let's snip this. I'm going to try something here. I'm going to copy it, and I'm going to close this, and I'm going to paste this in here just so that that's all done. Okay, so there's my data set. So let's get started. So I'm going to start with my hypotheses. Always step one is starting with your hypotheses. So my null hypothesis is that the standard deviation for McDonald's is the same for the standard deviation of Wendy's, which is 55.93 seconds. And then my alternative hypothesis is that they are not equal. This is a two-tailed test. And it's one sample. Step two, I'm going to put in my alpha level is 0.01. And step three, I can go ahead and I could summarize my data. I had 25. We did not do descriptive statistics, so I'm just going to pull in my, if I can find it, I'm just going to pull in my data from StatCrunch. Step four, I'm going to do a chi-square test. And my formula for my chi-square test is going to be, I'll do it over here, chi-squared equals n minus 1 times s squared over sigma squared. And we get our chi-squared statistic equals 62.05. Our p-value is 0.19. So our p-value, if it was less than alpha, it'd be statistically significant, but it's not. So I always use the less than so I don't get myself mixed up. So the p-value is not less than alpha, therefore this is not statistically significant. When something's not statistically significant, my step 5 is going to say fail to reject my null hypothesis. So step 6 is these data suggest that McDonald's standard deviation of service times is not different from Wendy's. And should McDonald's take any action? Okay, that's not going to be part of our 6-step test, but to summarize that, I think we would say it doesn't look like McDonald's needs to take any action. So when you have this and there's another question besides your significance test, you need to address that separately. So I hope this helps how to work through testing a claim with standard deviations.